how they are flow, hydrothermal, how it flows. Then a brief note on the transport of various case study. A case study. Of course, I'm just going to give a case study next class, coming Friday, on the role of fluids in mineralization of certain important metal deposits, taking our own India as a case study. Let us try to see what is happening. So to start with, what are hydrothermal solutions? And what is its impact? So as you know, people have understood that ore minerals can be precipitated from aqueous high temperature solutions. So when you say high temperature is qualitative, people have observed that the solutions above room temperatures, right from around 50 degrees Celsius, it starts operating in the crust. And it can go up to 650 degrees Celsius, or Lindgren, or some of the experimental studies. So these hydrothermal solutions can carry wide range of materials, very high density like gold, the dissolved form, and very light minerals like muscovite. The components doesn't carry the mineral, it carries the components, and finally when it's deposited, it becomes mineral like gold, silver, galena, sphalerite, muscovite, tourmaline sometime, albite. So different types of minerals, metallic, non-metallic, fluorite, calcite, quartz. So all these can be deposited from these hydrothermal solutions. What are these hydrothermal solutions? Basically water, it is predominantly water. And people, when geologists studied this water, high temperature, they found they are highly saline also. Number of places, the hydrothermal solution is saline. You do have modern hydrothermal solutions in number of places. They are called geothermal systems in Japan, in New Zealand, in other countries. Even our own country, India, we have a lot of geothermal systems. I don't know if anyone is coming from Dehradun. Sahasradhara, the word of Sahasradhara, that itself is hydrothermal system. The Puga, I don't know, anyone coming from Himachal Pradesh, Puga geothermal system. And in peninsular part of India, Tatapani, Chhattisgarh, there are certain springs along the west coast. There are certain hot springs along the central part of India, along Narmada River. Okay, and people found that they not only carry that water, sometimes they carry carbon dioxide, methane, nitrogen. They are all deep-seated. So these high temperature can be from the normal rock temperatures, because suppose let's consider that you have a crustal depth and you have certain deep flowing water, deep meteoric water. Here it is 25 degrees Celsius at the surface. When it starts going down deeper and deeper, the geothermal gradient keeps on increasing. So the water can attain its high temperature, and when it comes to the surface, it will come as thermal springs. In fact, this is the reason for many of the thermal springs. The most famous Faithful Geyser of America is also a geothermal system. So you can have 100 degrees Celsius to very high temperature, like 800 degrees Celsius, very high temperatures. So these fluids, of course, they are called a solution. Sometimes they are called hydrothermal fluids. So these fluids are liquid or gas, or sometimes mixture of both. The ore minerals can finally it has to precipitate, in the subsurface, in the form of open spaces and the form of cavities or replacement. All these processes takes place. Okay. At the interface between rocks and water bodies, of course, I should not use the called water bodies, because water body means we think of lakes and oceans. Yeah, sometimes you do have the hydrothermal systems in the oceanic environment, like the mid-Atlantic ridges, where the basalts are coming up, and there is a system for volcanogenic sulfides. Do have, but we don't call the water bodies. Any good solid, Kalega, and atmosphere. What are the products of this hydrothermal process? So you have ore deposits or mineral deposits. They are comparatively smaller compared to the crustal volume. They are few cubic kilometers in volume, but very concentrated, very valuable, metallic. A number of times they appear as accidents. It looks, suppose you travel, let's consider you travel from Delhi, okay? You travel to Jaipur, okay, is it right? Is it right, okay. So you find all rocks anywhere. Okay. So from Nimkathana or Kotputli, if you go towards further northwest, then you will come across K3. Find a huge deposit. Is it right? Or suppose let us travel from Bangalore, somewhere here. Okay, Bangalore to Raichur northern part. Okay, from Raichur you take a small bus. You go to a place called Hatti. Is it right? So there you have a huge gold deposit. So they appear as if some sort of accident has taken place, but something suddenly appearing. Hatti, Janagiri, or your K3, or your Rampur Agucha, your Rajpura Dariba. But they are not. They appear like accident, but they are not. They are controlled by certain physico-chemical processes. The formation was controlled by the PT conditions, by the physical process. Hydrothermal alteration was taking place. A number of veins you will come across, brachia you will come across. I'll show some pictures where you will see all these veins and brachias. Daksh is there?
Yes, sir. Yes, sir. I am here.
You said that you will talk for 15 minutes?
Yes, sir. So I have the presentation.
Your PPT is ready. Your voice is not clear.
So I have sent over the presentation and it is ready with me as well.
See, if your voice is not clear, then how you can give a talk?
Just give me a second. I'll disconnect my headphones and
set your computers properly. Yeah, get ready. 10:45. I'll give time. Now the time is 10:30. So you have brachias. Yeah, I'll show you some pictures. Yeah, yes. So what you find is rock. Of course, you do have some colorations here and there. Okay, yeah, there are reasons for it. Okay, so they are basically okay. These are rock fragments, but you find certain veins. See, there is a pen is kept there. You see, certain veins are there. Is it right? There are veins are there. Veinlets are there. Okay, these veinlets. All these things are products of the hydrothermal activity. Yeah, you see, huge rock. The rock, it's a boulder. It's mined. It has come out. Okay, so you find a rock. You find a vein. Of course, if you see very carefully, the vein has got further layering. They are called as the crustification. You find all these veins. Suppose you come here, this place, you find number of crisscrossing veins. It depends on the nature of the deformation, the geometry of the veins. But these are all the vein bodies. Yeah, you can see. It's this from a book. It's from a book called this Physical Geology. I just happened to download. You can see the veins cutting across the rocks. So, and if you try to study all these area very carefully, these are basically all hydrothermal veins emanating from Pluton. Not necessarily always they come from Plutons, but this particular area is related to Plutons. Yeah, these are beautiful vein. Yeah, yes. It's a foliation parallel quartz vein. I think you must have studied in structural geology. Have you got advanced structural geology paper now? Geological technology? Hello?
Sorry, sir, we didn't get it.
Can you repeat?
Can you repeat, sir?
You must have studied structural geology course.
Yes, sir.
In first year. Okay. And there is another course called Advanced Structural Geology.
Sir, we have Structural Geology 1 and Structural Geology 2, sir.
Yeah. Structural Geology 2 is advanced. Have you completed the
This semester, sir.
Huh?
This semester, sir.
This semester. So you will be studying all these veining pattern, no? Veins, brachiations, you must have shear zones. Is it right?
Yes, sir.
Yeah, may I know who is speaking?
Lamina, sir.
Good. Finally, your voice is coming out. Good. Finally, you have set your computer. Good. Very good. I'm happy. Otherwise, I was thinking that I'll give 0 marks to you in interaction. All right. Doesn't matter. Okay. Good. Yeah. Please read some books.
Okay, sir.
Yeah. Yes. So these are syntectonic quartz veins. You can see the shearing. It's basically a shearing. You can see the sheared quartz vein, or it's a quartz vein formed during shearing. Okay, so this is from underground mine from Karnataka, the most famous Hatti gold mine. So you can see the subvertical. No, not exactly, but subvertical. Yeah, yes. Vertical. You will have subvertical. You have subhorizontal. I'll show you. These are how the pictures are. I think structural geology you are studying. No, these are it's represented. The form of blocks. No, foliations, host rocks, conjugate veins, subvertical veins, subhorizontal veins. I'll show some of the pictures. Yeah, yes. So these are the subhorizontal veins. Where is it? Yeah, yes. They're not exactly horizontal, but subhorizontal. Yeah, yes. Depends on the geometry of the opening. The vein takes place. Veining takes place. Yeah, yes. These are irregular veins. These are all going in different directions. Irregular veins. Yeah, these are conjugate veins. You see. The veins. And if you see the materials inside, they will be carrying a lot of components. And sometimes they will be carrying a lot of metals. That's why it's called as metalliferous veins. Yeah, this is a calcite vein once again. So you can have different types of veins. To just show you. Okay, so where does this water comes from? You talk about water. Where does this water come from? What is the source of these dissolved elements? What are the pathways? Okay, how the energy is given to drive these fluids? Where are the deposition sites? What are the changes that takes place? So all these things you have to understand when you talk about hydrothermal systems. Let us first consider source of water. Okay, so people previously used to think that most of the water is coming from magma. But White was the person, was scientist who published a paper in economic geology. He said that the water, before 1974, people used to think that the water comes from magma. Because magma is storehouse of so many things. But he said that no. The waters can come from diversity of sources. They can come from different sources. You can have metamorphic fluids, you can have magmatic fluids, you can have diagenetic fluids during sedimentary process. Okay, and water can come from oceanic environment, it can come from meteoric water, it can come from sedimentary water. All these things can happen. And for that, what are the evidences? For example, if I tell that I am the president of India, will you accept? No, you will not accept. Is it right? Suppose if I say that I have got about 100 crores of rupees, no, you will say that how do you believe? I want evidences. Okay. So scientists were able to show that these waters were of different diverse origin based on fluid inclusions. Please read what is fluid inclusions. Please read what is fluid inclusions. They are micro objects present in the rock. Hot springs, yeah, yes. What you find in that Mussoorie, Dehradun Road, Sahasradhara, or the Puga geothermal system. You type geothermal systems in India, you will get a lot of materials. The deep drill holes people drill for geothermal systems in countries like New Zealand, Japan, in Canada, in Greenland. So when they were drilling, they encountered like the most famous drilling is called the Russian deep drilling program of Russia. They went for about 13 kilometers. So sometime they were losing the bits. So the diamond bits were lost. The reason was this diamond bit was interacting with the very, very alkaline type of solutions when it was encountering in the bottom part. So it was encountered a lot of geothermal systems. So it corrodes, it reacts with the metals and the other components. So they were losing the drill bits. So all these things can be evidenced or can be evidences for the hydrothermal systems operating within the crust. Jaglan, tell me. When you are ready, tell me. I'll give after 5 minutes. I'll give. Yes, you should know about circulation. For example, this one I told the oceanic water. Like for example, most of the Atlantic ridges or the Pacific rise, wherever the basalts are coming out. Okay, so you have the basalts and it is interacting with the rocks. It will develop a lot of fractures. So the ocean water will go inside, and after some time it will come out. So during this process, it will deposit certain metal components. It will leach the metals from the rocks and it deposits. So we have a number of black smokers and white smokers in the oceanic environment. It is because of this type of circulation of oceanic water. For example, you have a felsic pluton is coming up or already existing at the bottom. So that also can set these hydrothermal solutions set. For example, you have the sedimentary basins, is it right? The aquifers, the deep aquifers, If it is very deeper, then because of the geothermal gradient, it can attain high temperature and it can start moving. Okay. For example, these are the gravity-driven geothermal systems. When it goes to the deeper and deeper part, because of the thermal conditions, they attain very high temperature. When it comes to surface, very high temperature waters. So during this process, it will liberate a lot of metals. That's right. These are different stages of oceanic environment. At the same process, it is given better. This is the shear zones. In structural geology 2, probably you are studying, there are a number of shear zones where metamorphism is simultaneously happening. You have metamorphism, structural deformations. Number of times they are co-generating. They simultaneously operate. So in such a condition, what will happen is when the metamorphic waters, they can be focused along the shear zones and they can travel for a long distance and they would deposit in second order, third order structures. Is it right? Have you heard of the second order structures, third order structures? Let me ask someone. Let me ask Devansh. Devansh?
Yes,
Devansh
sir.
is there?
Yes, sir.
So have you heard of primary structures, second order structures, first order structures? Devansh Pandey. Please read. Please read. Important. If you want to understand, you have to understand. You have to read. Yeah, this type of
It was structural geology.
pardon? What?
It was there in second year, first semester structural geology.
Please read. Yeah, now also read. Why, can you give us a talk on the first order, second order, third order structures? Devansh Pandey for about 10-15 minutes next class.
Okay, sir. We'll see.
Please give a talk. Devansh Pandey will give a talk for 15 minutes on first order, second order, third order structures.
Okay, sir.
Main related shear zones. So this type of fluid circulation can give rise to different types of deposits. For example, you have the shallow circulations, the meteoric water circulations. Shallow circulations can give rise to certain deposits like VMS type of deposits, volcanogenic massive, sedimentary exhalatives. Okay, there are certain connate waters it can circulate. So all these things will finally enter into hydrothermal systems, whether it is the surface water, whether it is connate water, whether it is metamorphic water, the deep magmatic water. They will all form a hydrothermal system, and the system at different depths, when it is emplaced, they can give rise to different types. For example, orogenic gold deposits at a deeper level, skarn deposits slightly higher. Okay, epigenetic gold deposits, mesothermal deposits. The epithermal deposit is slightly at higher Mississippi Valley type of deposits. Okay, iron oxide copper gold deposits of Olympic Dam. So you can have different PT conditions giving rise to different types of deposits of copper, gold, silver, uranium. Okay, different types of deposits can form. All these are available in book by Rob. Anyone of you have got a book called Rob? Download book called Rob. Jay?
Yes, sir, Rob Lawrence.
Yeah, Lawrence. Please read Rob Lawrence. He gives a lot of details on this resulting mineral deposits, circulations. Excellent book for hydrothermal process. Excellent book. Okay, we talked about, we saw the source of metals. Now let us try to see the, source of water. Now let us try to see the source of metals. Where from the metals come? Is it right? So the first option is given is rocks can act as source of elements. Because there are a number of rocks. If you try to analyze, basalt, basalt will have copper, basalt will have lead, basalt will have zinc, basalt will have gold. It will not have uranium. But if you analyze granites, it will have uranium, it will have thorium, okay, it will have fluorine. So when the fluids are acting on all these rocks, so it can leach the metals and it can follow certain transportation path. The rocks itself can act as a source of elements. Another one is magma. Yeah, magmas are the real storehouse of many incompatible elements, which will not be accommodated the crystal lattices, because when the magma is crystallizing, to start with, as you people have written the seminar or your assignment on the Bhavan's reaction, no? It will start crystallizing with olivine, then pyroxenes, then it will come to plagioclase feldspars, no? So a lot of things are happening with the major silicates. So what are the minor components available in the magma, like wolfram, like tantalum, uranium, molybdenum, cesium, rubidium, all these things will not be able to enter into silicates. No, because the ionic size are different, ionic charge is different. So because of these, they will not be able to enter into the rocks. So they will be always incompatible within the magma. So in the magma, more and more water will get concentrated in the lakes, because that's why to start with you have anhydrous minerals. At the later stage you have hydrous minerals. You try to see olivine, no water. Pyroxenes, no water. Plagioclase feldspars, no water. But you come to muscovite, biotite, all water carrying. Is it right? So more and more water will be there in the magma, and you at the same time you have incompatible metals. So you have heat, you have metals, you have water equally with the magma. So these hydrothermal waters can carry a lot of metals, and the metal solutions, fluids, are always will be in the movement. So given a condition, the fluids will start moving. So that is one case. Another case is deep burial of sediments. I'll just show you pictures how the deep burial of sediments and the increase in the temperature and pressure can leach the metals, okay, which can form the carbonate-hosted lead zinc deposits. So another is sedimentary rocks. The sedimentary rocks itself, because when the sedimentary rocks are deeply buried, because sometimes you have about 2 kilometer thick sediments. So the sediments at the top will be having 25 degrees Celsius, at the bottom will be having 100 degrees Celsius or 200 degrees Celsius. So naturally the metals present in these will be active, the water will be expelled, so the metals also will try to come out. So there will be always interaction between water and the sediments. So all these processes are happening. How many of you have seen sedimentary rocks, thick sedimentary rocks? Lavina? Have you seen thick sedimentary rocks? Have you ever seen thick sedimentary rocks? Lamina is there in the meeting or not? The class or not? Lamina,
Yes, sir.
have you ever seen a thick sedimentary rock?
Yes, sir, I have seen.
Where?
Sir, normally in pictures, sir, not outside.
Yeah, you should go to the field and see.
Okay,
Should
sir.
go to the field. Are you from Kadapa area?
No, sir, no.
How far Kadapa? How far? Have you seen Tirupati?
No, sir.
Please try to go to all these places and see. You have thick quartzites, all sedimentary, metamorphic sediments.
Sure,
1
sir.
kilometer long, you see right from the whole hill section, you can have 1 kilometer, 2 kilometers. People coming from Madhya Pradesh, Indian sediments, people coming from other places, Gondwana, like the Chhattisgarh or even the Jharia, Jharkhand, you will have sediments of 1 kilometer, 2 kilometer, 3 kilometer thick sediments. So when the sediments at the bottom definitely will be having high geothermal gradient, so that leads a lot of metals present sediments. I think we will ask our probably Jaglan is ready. Jaglan, you are ready? Jaglan? Jaglan? Mr. Jaglan? कुछ गड़बड़ है
सर ये मेरे ख्याल से वेबएक्स के साथ कुछ प्रॉब्लम है सर. आई एम गेटिंग गुड एमबीपीएस स्पीड एक्सेट्रा, बट आपकी आवाज भी कट जाती है, एंड सेम इज गोइंग ऑन विद मी एज वेल.
Can you share your PPT? I will come out.
Yes sir. So I will just share.
Yeah, let stop sharing. My internet is all right, absolutely all right. Yeah, come on, share. Let me see. Let us listen to you for about 10 minutes.
Yes sir.
Please share.
So is my screen visible, sir?
Yeah, please. Yeah, very good. Come on, talk.
Yes. So today I'm going to be talking about magma mixing and what it is and what are the principles that lie behind the whole process of magma mixing. So the processes that are taking place inside the earth, specifically the magma chambers, can be divided into two parts. One being fractional crystallization, which can also be termed as magma splitting, and the second one being magma mixing. So fractional crystallization, as by the means of all the write-ups that we have been giving, we have understood what the Bowen's series of reaction is. And basically, the whole principle that lies behind it is that fractional crystallization, that is different elements, different materials have different range of temperatures at which they crystallize, which causes crystallization of magma at different temperatures, giving different composition of materials. So that is what fractional crystallization is, which is the sole reason for magma splitting. Coming on to magma mixing and the whole crux of the matter, magma mixing is the process by which two magmas meet, commingle, and form a magma of a composition somewhere between the two members. So, for example, let's take into account a magma chamber A and a magma chamber B. So, due to some reasons like injection, etc., they can get connected, and once they are connected, and as and when the magma chamber A comes in contact with magma chamber B, certain different things happen. And what are the reasons for those different things? Might be density variation, temperature variation, or convective stirring. So this whole process was first observed or published by Bunsen, and we are going to just develop on that further on. So this is the whole process of magma mixing. So before starting, let me give you another basic concept about magma mixing. Magma mixing is a common process found in volcanic magma chambers that involves chemical mixing. Chemical mixing. Take that in mind. It's chemical mixing of two or more magmas, causing a change in the composition, temperature, and density of the final magma that is being formed by the hybridization of the two magmas that mixed. So this happens due to the following reasons. One, maybe temperature variation. That is, the temperature of magma A might be different from temperature of magma B, which causes the mixing. Or second, it can be density variation. So to understand more, here is a case where silicic magma is being injected by mafic magma. So as you all know, mafic magma has a higher rho when compared to silicic magma. That is the whole reason why it's staying stuck beneath. In the next, it is stuck to the floor because of the density variation. But as mafic magma has a higher density of certain minerals that silicic magma does not have, mainly Fe, etc. So certain blebs of minerals start floating above. And why does this happen? Because there is a temperature variation. Temperature variation in both of these magmas. What happens because of temperature variations? Convective stirring or convective currents start happening. And these convective currents are the reason for the formation of these blebs and the movement of these blebs upwards. So, moving on with the process, magma A and magma B. So, magma A is what we have called as silicic magma, and magma B is the mafic magma. Due to convection currents and density variation causing mafic magma to stick on the floor, and due to convective currents, certain small blebs, convective currents and density variation, certain small blebs of minerals start going above and mixing with silicic magma. Then there is the formation of the hybrid magma. The new magma is a different temperature, is of a different temperature and a chemical composition altogether. But we cannot say that it is completely homogeneous. Like in case of hot water and cold water, if we mix hot and cold water, we can say that the whole mixture is homogeneous after some time t. But in case of magmas, we cannot say that because it is a very slow process, and we have found evidences of these blebs in the outcrops that we have found. So next on, we are going to discuss the certain evidences that led to the development of this theory. So textual evidences that lead to the development of this theory. First being enclaves. What are the enclaves? The mafic blebs that we discussed in the previous slide are the first insight about the first textual evidence about the magma mixing. So what happened is a mafic enclave was found in a silicic environment. A bleb like consider this to be a thing, and this bleb is there in the outcrop that we found. So this is only possible by the means of the process that I explained earlier, which can be explained by magma mixing. Now, second, we have crystal zonation. So stable crystalline formation will respond to the magma composition changes that will be occurring. This is true because like we have studied fractional crystallization to some extent. So if there is any change in the composition of the magma, the crystallization of that magma will change as well. because there is a drop in temperature or there is a drop in the composition that causes a change in the composition of the magma. And because there is change in the composition of magma, zonation of certain crystals takes place. Now, these zonations can be of two types, one being continuous and second being oscillatory and continuous. This is an example of continuous zonation, and this is an example of oscillatory zonation. So what happens in oscillatory zonation is we get a tree-like branching. See this? We're getting zonations in the form of tree rings. And in case of continuous zonation, there is a continuous change that is happening from the center towards the outside. So these two types of zonation also led to the belief that there is some compositional changes that have been happening in the magma. Now the third structural evidence was crystal resorption. So what is crystal resorption? Basically, consider a fact that there was a crystal. I'll focus on to this more. There is a crystal like this, and as and when the temperature increases, the crystals starts degrading and chipping off. This is the whole process of resorption. So resorption was also a textural evidence for the whole magma mixing theory. So summing on to that, like this was the seminar that I had. This is just a basic of what magma mixing is and what are the various ways and methodologies that define the whole process of magma mixing.
So, Jaglan?
Yes, sir.
Of course, let me first appreciate you that you made an attempt. I appreciate that. How many of your classmates did they understand what you taught?
Sir, I hope they did. I explained in a very layman's term.
So you please get the feedback from them. Because you people have a common WhatsApp group. Is it right? Is it right? Do you have a common WhatsApp group?
Yes, sir.
So you find out from them how many of them they understood. Okay. Number two, in your talk you use certain terms like oscillatory zoning, resorption, all these things. Okay. Enclaves. So while you are preparing the talk, did you feel that I could see all these things in the field or in the microscope?
Yes,
Because
sir.
you cannot believe. For example, I say that I am having 2 kilograms of gold. Is it right? Suppose if I put off my camera and I say that I have got 2 kilograms of gold, 2000 grams of gold, so you will not believe. You will not believe unless I put on my video. I really show that yes, I have got 2 kilograms of gold. Is it right?
Yes,
okay.
Sir.
So unless all this process, you will be able to appreciate or you will be able to understand when you see all the features in the field as well as under the microscope. Is it right?
Yes, sir.
So that is the need of going for field work as well as doing the practicals in the petrology lab. Otherwise, nothing you will not able to understand anything. It will look as if they are all stories, just like Mahabharata, Ramayana. Okay?
Yes, sir.
So that's why field work and laboratories are very important for geologists and geophysicists people. Anyhow, because of the pandemic, we are struggling. Let us hope that you people will come back sometime. Let us hope something will happen. Yeah, good night, very nice. At least I'm happy that you must have understood something in this process. You refer to something. What is the book that you refer to?
So, firstly, I referred to certain articles that I found on Scholarity. It was no clear book that I used, but I used these articles for developing the theory because they haven't given clearly what magma mixing is, just short components of what magma mixing can be.
Okay. Do one thing. Share those journals and articles to all your classmates. And send a copy to me. Okay? Send a copy to me. And my sincere suggestion to all of you: don't copy from internet. Don't copy the slides from internet. Read and make your own slides. Or prepare your own slides. Don't copy. These are my sincere suggestions. Okay? So these are how you develop. Yeah, okay, all right. I think today time is already 10:59. I have a meeting at 11 o'clock. We started a bit late because of the problem in my laptop.